Okay, question 10 is a modulus function question. The first two parts are reasonably straightforward, standard questions. The last part is a little bit more tricky. In fact, I would almost classify as a bit of a trick question, but we'll get to that. Something that you theoretically should be able to do. Um, so the first question is simply sketching the modulus function. If you need to, sketch the regular function first without the modulus. That's not it. So a couple of axes, and it's just going to be a gradient 3 with a negative y-intercept. So something like that. And that would be y equals 3x minus 2a. And the y-intercept here would be minus 2a. And the x-intercept would be if y equals 0, 3x equals 2a. So this would be 2a over 3. So the x-intercept is 2a over 3. So for my actual answer, I just need to reflect the negative part up to the positive. So again, a couple of axes. This is going to be hopefully slightly neater. And then here comes my the normal part of the graph, and then it's going to bounce off here. Try and get it vaguely symmetrical like that. Okay, so that is my, now it has asked for the coordinates, so let's answer the question exactly as it asks. So this is 2a over 3 comma 0, and the y-intercept now is positive, so it's 0 comma 2a. Okay, why not label the y-axis just for good measure and the x-axis, and let's label the graph mod 3x minus 2a mod. Okay, so that is my answer. Okay, now question B, we have to solve an inequality. Again, I think a sketch here is useful. I don't really want to ruin my answer to part A. So I'm going to sort of slightly more quickly, hopefully, recreate that sketch because I don't want to wreck it. That was my answer to part A. I don't want to draw all over that really. So I'm going to quickly draw that sketch again. And I want to add on to that graph, the graph x plus a. Well, x plus a is gradient 1, and this was 2a, so it's going through a. So it's going to be something like this. That was meant to be a straight line. It's not very straight, but never mind. So this was 2a. This is now a here. This is 2a over 3. And this is the graph y equals x plus a. And this was y equals mod 3x minus 2a. So where is the modulus function less than or equal to the other one? It's between here and here. I just need to work out what these x values are down here, okay? And it's going to be this interval here. It's going to be a closed interval because it's less than or equal to. So do pay attention to that as well. So basically we have to work out these two intersections. And I don't know if we want to be really posh about it, we can label those. So B is what I call the positive branch, where we can just ignore the modulus signs. So at B, we've got 3x minus 2a equals x plus a without the modulus. So solve that, take away x, add 2a. So we've got 2x equals 3a. X is 3a over 2. And then the other one at a, so at a, this is what I call the negative branch. So that is the minus of the modulus function, 3x minus 2a, which is still equal to x plus a. And then we need to solve that. So that is minus 3x plus 2a equals x plus a. Add the 3x to give us 4x. Subtract the a to give us a. And then that gives us x is a over 4. So our answer is this interval here, which is a over 4 is less than or equal to x, which is less than or equal to 3a over 2. Okay, if you want to use set notation, you can do. It hasn't actually specifically asked for it, but that would be the set notation. Some people got confused about this expression solve in terms of a. By solve means we want to find x. Okay, because it's an equation in x. X is the variable. A is just a constant which we don't know. That's not the same thing as saying it's a variable, right? It's just it's a constant, but they're not telling us the value of it because they don't want us to plug it into our calculator. So when it says solve, you've got to find x in terms of a. So instead of just saying x is between 5 and 6, we're saying x is between a over 4 and 3a over 2. Some people answered it the other way round and they found a solution for a in terms of x. That's not what they're after here. So please make sure you understand the language there. So that is the answer to part B. Now the third part is the tricky one. It says given that the modulus of 3x is less than or to equal to x plus a. So in other words, given that the restriction from part B is applying, so we have this limitation on the value of x. Given that that is true, find the range of this function g of x. So that means the y, the spread of values in the y direction, the range of the function. So again, I am a big fan of sketching. And this is not a totally trivial function to sketch. My preferred approach is there's a couple of ways you can do this. My initial reaction is to build up the sketch in stages. And I'm just going to rewrite the equation down here. So it's 5a minus mod of a half a minus x. So g of x is 5a minus mod of, I'm going to have to check again, a half a minus x. Turning a page is a very dangerous thing to do in maths. And if you are having to copy something over a page turn, keep checking back to make sure you haven't miscopied a minus or something like that. Okay, that is the correct function. Now, the sort of I thought actually afterwards of a better way of doing this, or maybe a slightly better way. But the way I tend to do something like this is build it up in stages. So this is part C. I would start with just the modulus function. So in fact, even with that, you could even start a stage earlier than that. So what does a half a minus x look like? That is a gradient of -1 going through a half a. So that is a half a, and it's going to be a half a here as well because it's a gradient of -1. What happens when we then stick a modulus sign round it? Well, again, the negative part bounces, so it's coming down here and then it's going up here. So that is a modulus of a half a minus x. Now what happens when we make it negative? So the next stage is to make it negative, and what that's going to do is it's going to turn it upside down. So it's going to come up here and down there. Whoops, let's turn that into a straight line magically, and down there. Okay, oh, this was a half a, and this was a half a. So that is still the case. That is now minus a half a, and that is a half a. And now the last part, so this is minus the modulus of a half a minus x. We now just need to shift it up by 5a. Okay, we need to do a vertical translation by 5a. So what's going to happen now is the um, the whole thing moves up. So where it's currently the value of the function is 0, that is going to be 5a. So if this is 5a up here, it's going to, this vertex here is going to be up here. It's then going to come down through here, where this is 5a. So this is minus a half plus 5a. So this is 9a over 2, or 4.5a. Okay. It's then going to come down this way. So this value here is half a. That hasn't moved. This value over here might be interesting. Remember, we're coming down here with a gradient of -1. So if we're going down 5a, we're going across 5a. So this is going to be 5.5a, which is 11a over 2. Now, we want the range of the function. So as it stands, the range of the function is anywhere from -infinity all the way up to 5a. But we've also got this restriction that we are going only allowed to go from a quarter a to 1.5a. Okay, so a quarter a is here. Sorry, that's a quarter a. That is a half a. This is this is a long way away. This is over 5a. So 1.5a, it's not quite symmetrical, is it? Because that would be 3/4. 1.5a is somewhere over here. Let's call it there. 3a over 2. Okay, so the range, so we're restricted to this interval for x, in which case this is clearly, I hope clearly, because this is a bigger gap. This is going to be the lower value, and this is the upper value. So the range is going to be this interval here. So we have to work out what that is. Okay, so we know the 5a. We just need to work out when x is 3a over 2. So when x is 3a over 2, g of x, I'm going to run into my diagram, g of x is 5a minus the modulus of a half a minus x, which is 3a over 2, which is 5a minus, and then a half minus 1.5 is -1. So it's the modulus of minus a, which is 5a plus a. Sorry, it's 5a. Be careful here. That is 5a minus the modulus of minus a is a. Just ignore the minus. So that is 4a. So that makes some sense. So although my diagram's not very good, actually it's not too bad. This value here is 4a, which is actually just less than that. Okay. So that is the lower limit. We know the upper limit already. Therefore, the range is 4a. 4a is less than or equal to g of x, which is less than or equal to 5a. I'm just going to quickly check to see if that's correct, because I don't have 100. Yes, it is. Okay, that is the right answer. Okay. I did think about the sketch just in case you wanted to carry on listening. In terms of the sketch, rather than doing this series of transformations, another way you could tackle it is you've got g of x is 5a minus mod half a minus x. You could simply look at it from the point of view of if the modulus is positive. So, and that's going to be that the requirement of that. So if a half a minus x is greater, or let's call it greater or equal naught, then g of x is 5a minus just the thing without with a bracket instead of the modulus. So that's going to be a minus a half a plus x. So be careful. So that is basically x plus 4.5a, isn't it? So 9 over 2a. And that's going to be the requirement here. If we rearrange that, that is x is less than or equal to half a. Okay. And then the other possibility is if a half a minus x is less than naught, then g of x is 5a minus the minus of the bracket. So it's going to be plus a half a minus x. We'll be super careful here, which is 5 and a half a, which is 11 over 2a minus x. So rather than doing all of these transformations, you could basically break the function down into the two pieces, and the inequality here is x is bigger than half a. And you could use those two pieces to do your sketch. So we get the same thing here. So if x is bigger than half a, we've got this 11 over 2a minus x. So it would continue up here and it would intersect at 11 over 2. And if x is less than half a, it is x plus 9 over 2. So that confirms the 9 over 2 intercept there, and you get that line. So you could draw those two pieces separately using these two equations rather than doing the transformation approach. Whichever one you prefer. I'm thinking in hindsight I might prefer this one, but I've always done it this way for some reason. But anyway, that is question 10.